Hey there, Alex. It's great to finally connect and to have you on the podcast today. I know it's a little early there, and as you've just mentioned, you've just got your firstborn that's come into your life. So I really appreciate the time that you're taking. Now, I'm sure that most people in this space who are familiar with molecular hydrogen are, to at least some extent, familiar with you and your work, especially as you've been on the podcast circuit a lot in recent times. But for those in the audience who maybe just aren't familiar with you and your story, would you mind just running us through how you ended up in this space?
Yeah. So this would be going back about a decade, maybe a little bit more. Um, I was in a completely different field. It gave me a lot of freedom financially and time-wise. And so my time was spent largely exercising, and competing in a little bit of competing in CrossFit, but helping friends get prepped for fights in martial arts. I was training 4 to 6 hours a day, and I got hit with a mystery virus. It caused an autoimmune-like response. I developed sudden onset narcolepsy. I was sleeping 16 plus hours a day. If I sat down for more than a minute, I'd fall asleep. That was a narcolepsy aspect. And I had central nervous system fatigue. So my strength was normal, but I couldn't do anything explosive, like couldn't jump an inch off the ground, basically.
Sorry to interrupt. Was there anything sort of postural then, sort of a POTS component, do you think?
Uh,
A postural orthostatic hypertension sort of element to that, just with that sort of CNS fatigue, or it just sort of screams that that sort of autonomic dysregulation to me, or do you think there was another underlying trigger there?
yeah, I mean, for hypertension, my blood pressure by memory wasn't that abnormal, but
Okay.
um, that was something, especially when this happened. My resting heart rate was in the mid 30s. My blood pressure was like 100 over 70. I remember it spiked a little bit, but nothing that the doctors thought was concerning. What was the most concerning is my C-reactive proteins, which were 35 milligrams a liter,
Wow.
which is like,
Borderline cancerous. Yeah.
yeah, it's 100 times abnormal, and now mine are undetectable. So, 150, 200 plus times higher levels of inflammatory markers than what I currently have. So that lasted a few months, and all of a sudden the dust cleared, and things started settling back down to normal. And by normal, I mean my CRP dropped to like 3, which is still what you'd expect when you're sick, when something is going on, but not 34. But when that happened, I had developed osteoarthritis in 11 joints. So the high levels of inflammation for months had basically ravaged every joint that I'd had a previous injury in. Doctors told me that I should never work out again, put me on high levels of like anti-inflammatories and cortisone injections. And I just knew that wasn't a forever solution at 29 years old and having my life largely been about fitness and exercise. So I just dove deep into what we now call biohacking and looking for absolutely anything that could regulate the inflammatory response. I came across research on hydrogen water, and bought a machine for like $5,000. Went on my merry way. I was doing countless other things, various supplements, various, therapies, doing cold exposure, sauna, like doing all this stuff, and also was doing the anti-inflammatories and the cortisone injections.
Your gut
It
must have loved you.
Yeah, about 9 months in, I fainted in the gym a few times. Uh, I wasn't processing my nutrients, I developed multiple ulcers. So I had to abruptly stop the anti-inflammatories. Then my inflammation spiked again. All my joints froze. I couldn't put on a shirt, had to lie down to put on socks type thing. And I had to go back to the drawing board because obviously none of the biohacks I was doing were properly working. Only the drugs were working. And dove back into the research, and I found new studies on hydrogen water and molecular hydrogen. And they kind of pissed me off because I had this $5,000 machine and it was doing nothing for me. But it just dawned on me, well, what dose am I getting? And what dose are they using in the research? So I started buying the full papers to read the material and methods, quickly discovered that not a single one of the clinical trials was using an electrolysis machine like I'd bought. They were all reporting concentrations and dosages of H2. I had no idea what I was getting. I found a reagent to test the hydrogen, and it was undetectable. I had to triple the input to detect anything. So it was, 0.03 parts per million is what I was getting, which is a small fraction of the minimum observed therapeutic threshold to have any physiological effect. And the minimum threshold to do anything in the body is not what's going to work or work the best, for anything. So that gave me a bit of hope. And there was nothing commercially available other than these electrolysis devices. And I started doing some tweaking, and then I found there was some emerging stuff coming out, and I started testing it. It had loads of problems, but basically between my own jerry rigging of getting these reactions done and trying to maximize it, I started getting to about 3 parts per million and drinking several liters of the water a day. I was pressurizing it in thermoses. A few actually exploded in my fridge from the pressure buildup. So that was a fun issue. But within a week and a half of getting in this high daily dosage of hydrogen, my joints all loosened, and I started feeling energy again and feeling better. And I started thinking, wow, there's something here. But I had a bit of a sober second thought, because I was using elemental magnesium, doing this reaction, and I knew enough about the basic chemistry to know that I'm making hydrogen, but I'm not a chemist, and I didn't know if there were any side reactions that were making something toxic or harmful. Am I doing something
Metals in the
wrong?
magnesium.
Exactly. Are there heavy metals? So I tested the magnesium I was getting, and I'd pulled in this magnesium. I'd found sources in Eastern Europe and in China, right? Because the stuff controlled in the US, eventually, which is what I'm using a pharmaceutical grade of the magnesium, but I had to go through an extensive background check to get it and export it, through the State Department, because it's heavily controlled, right, in the US. And the stuff I was getting in from Eastern Europe and China was never labeled as magnesium. It was always something like silver paint powder, right? Because I learned it was illegal for them to export. So I tested it. The heavy metals were high, but not dangerously high, high to be doing every day for the rest of my life.
Yeah, chronically.
Exactly. And I found my founding partner, Dr. Holland. He's a PhD organic chemist. He's originally from the UK, actually. And he's from the pharmaceutical industry. And I asked him to take a look. At first, he told me, I'm going to save you the money. This is the worst pseudoscience I've ever heard in my life, and gave me a long list of reasons why this wouldn't have a physiological effect. And even if it did, why you'd want to inhale rather than drink. Fortunately, I had read every single paper at that time on molecular hydrogen and its physiological effects, including data head-to-head from drinking water to inhalation and the difference in bioavailability in different organs and tissues. So I shared this with him. I rebutted every one of his points, and he said, well, I'm shocked. I still don't really believe it, but here's, there's enough for me to take a look for you. Sure, I'll take a look. This is my rate. And he went on looking at my formulation and the chemistry, and every day I just sent him a new study, just to pique his interest. I was really excited at this time because it had had such a profound effect on my own health, and I wanted to keep doing it. Uh, and serendipitously, I sent him one paper on a certain disease model that I was not aware of, but he was a lead chemist developing small molecules to target that disease at the time. And it was a phase two-ish style, like double-blind clinical trial. And he called and asked if I wanted to meet for lunch, and that he had some findings for me. And he'd made some tweaks to my formulation, but importantly, he wanted to talk about that paper. And he said the other papers he was just having to trust the conclusions because he wasn't really a subject matter expert. But he remarked that he was on this model and told me he was developing small molecules for it, and he wishes the molecules his company was developing worked as well as this paper. And he basically said, "Are you sure you just want this as a do-it-yourself project? Like, nobody's doing this. You're sure you don't want to commercialize this?" And I thought long and hard about it. I thought, who am I to enter this field? I have no background in this field, right? I don't want to go into something that requires expertise and just be pushing something that I don't understand. But I'd also promised myself, because I'd abandoned some business ideas that years later other people thought of and went and distributed. So I'd promised myself that I'd never let an opportunity like that slip again. So I started doing my due diligence. I spoke to attorneys. The first attorney I spoke to, because I was thinking about raising funds, and if I was going to need to, and I didn't want to, but if I was going to need to, what it would go.
Bootstrap this, yeah.
Yeah, and he basically, I told him what I was doing and the research, and by this time we'd actually developed a tablet that was working. And after an hour meeting, he said, "Listen, I'm not going to charge you for this meeting, and I'm not going to charge you to get all this set up, so long as you shake my hand and say that I'm going to be your corporate attorney as you get going." So that gave me even more faith that, okay, maybe
there's something here.
there's something here, right? And I'm getting this kind of encouragement. And then I hand pressed bottles for about 40, 50 friends, family members, friends of friends that were dealing with various chronic pain issues, especially exercise related. And the response was just overwhelming. Everyone's like, "What did you give me? This is like magic. This is fixing this or fixing that." And all of these confirmations along the way kept me going. The first year and a half was arduous. It only took a few weeks for us to finalize a formulation in a mortar and pestle, making 20 at a time. But making millions at high speed is a different beast entirely. And it was 15 failed scale-up attempts over a year and 3,000 iterative adjustments to formulation and process before we got our first working formulation that didn't work nearly as well as those first hand-pressed tablets. And to be frank, even the tablet we have today doesn't work quite as well as the first hand-pressed tablets, because everything you do in manufacturing can take away, but we're pretty darn close to what we did day one. But now we're at least 10,000 iterative adjustments into formulation process to continue refining, continue perfecting, and be able to make it high speed. But now I had a working product and I could make it. But the next question was, do I want to just be like a zealot believer, or do I want to put my money where my mouth is and see if this does work? Because I can't look at myself in the mirror. I can't sleep if I think that I'm just being a fraud, right? And don't know. So I set out on the next task. I emailed every first and corresponding author on every single human study on hydrogen at the time, and quite a number of the rodent studies, offering free product, free placebo, and donations if they wanted to use my tablet in the research. I got some bites, it kept going, and I'm a big believer in truth. So how most companies conduct research is when they're paying for research, it's under a research agreement, and results can only be published if the funding body like agree with the findings, right? I just don't believe that's ethical. We don't know the truth if we don't know what doesn't get published. Because if it takes a company 10 times to find the result they want, then it doesn't work. Didn't work 9 times, right? So
Cherry picking data at its best, yeah.
exactly. And this has allowed us, like, we have over 20 clinical trials now. We have more clinical trials underway than we have published. But because at every step of the way, I'm allowing researchers to publish no matter what the outcomes are, right? They can publish if it doesn't work. They can publish if it shows harm. This allows them to get grants, from governmental bodies and agencies and their institutions to pay their salaries. So the research we've done would have probably cost in the 9 figures, but it's cost us maybe $1 million or $2 million. I haven't done the math, right? But we've done the research for 1/100th the cost of what most private companies do, because we're taking this risk and we want truth to prevail. And if we found out it didn't work or it's harming people, then I wouldn't have been able to continue on in the business anyways, right? So I didn't want to be beholden to this whole shareholder primacy, which is the biggest evil that's befallen the Western world, that I have to do everything to protect earnings. Either this is showing that it's working and helping people, or it's not, right? Because I can always find something else to be my purpose and make money, but I'm not going to do anything for the purpose of making money, right? Money is a tool for your purpose. It's not the purpose, right? So that's why I structure things the way I do. And at this time now, we have 21 structure function claims legal to like FTC, FDA standards in the US. Like I mentioned, we have over 20 clinical trials, a bunch of preclinical trials. We have more clinical trials on the hydrogen tablets than every other commercial hydrogen water product combined. And we have more underway than we have published. So our lead is just growing because of our philosophy for truth and for science. And again, really, it was a put your money where your mouth is. Like, I'm a believer, but I'm ready to be proven wrong, right? And let's see what the data shows.
Well, thank you for that. That was the most comprehensive introduction I've ever had from anyone. So that was amazing, and definitely just speaks testament not only to your character but the amount of effort you put into this and just trying to overcome your own issues. I'd love to come back to the tablets a little later on in the conversation. That's okay, as I've got a few more questions there. But just kind of a quick tangent. I mean, I can't do a podcast without going on a tangent quickly. Did you ever find out what was really triggering your RA or the other subsequent issues? Was it sort of mold issue or anything like that? Or
They think it was a viral infection, right? It might have hit me a little bit different. So my roommate at the time, who was also a high-level competing athlete, it hit him different. He had to go to the hospital a few times. He had pneumonia. He missed a few weeks of work. He didn't have the long-lasting effects I did. I think what might have contributed to what happened to me is about a month prior, I stupidly competed in a CrossFit competition about 2 days after I'd had food poisoning.
all right,
And that left me so wrecked that I had like borderline rhabdo. Like, I couldn't walk up the
jeez,
stairs. Like, I slept on the couch because, like, in my house, I was on the 2nd floor, and like I couldn't make it up the stairs. So like for a couple of days, I slept on the couch downstairs as my legs were like shaking and not recovering.
really
Um,
healthy, yeah.
yeah. Again, I should have dropped out of that competition, but I was 29 and stupid and thought I was invincible. So I imagine that gut disruption and severe stress following of trying to compete after food poisoning is what triggered the response to the virus that I got.
Yeah, no, I look, I'm not going to judge you. I grew up a competitive cyclist, and it's a lovely sport. It's very safe until you fall off, in which case it's not. But yeah, no, I sort of trained myself into oblivion. I gave myself a benign bradycardia. Same vibe. Used to sort of train until you threw up and your nose bled, and then sort of wiped it down and just carried on. And then all of a sudden you hit that critical threshold in your 20s where everything just starts to fall apart. It's like,
there's a quote from a jiu-jitsu competitor that I like quite a bit. When you hit 30, you no longer get injured. You start collecting permanent disabilities.
I like that. Yeah, and I think, there's definitely a law of diminishing returns, as you know, when it comes to exercise. And I suppose it's quite a nice sort of way to sort of segue into the rest of the conversation. It's a bit of a hormetic stress is a good thing, but too much is detrimental.
Yeah, I mean,
Um,
this is a book I'm writing that I hope to release by about July called Stress Hacked. And it's not just
okay.
the body, it's the mind. So it's two books. They meet in the center, inverted, kind of like yin yang, because
Oh
we
wow,
can't be
that's
strong in
novel.
body without strength of mind, and we can't be strong in the mind without health and strength and vigor in the body. But all of it, I mean, hydrogen is a hormetic stress. It's just a very mild one, right?
Yeah,
And with every hormetic stress, whether it's emotional, psychological, whether it's physical, you need a certain threshold for it to be therapeutic. But if you go too much, it can be harmful. And typically, when you do too much, it's more harmful than the absence of it. And
yeah,
the right dose for any type of stress, whether it's physical or mental, depends not just on the individual, but intra-individual every day. What other stress do you have? What is your current state, right? So that CrossFit competition that ruined me was no harder than any other one I'd done or my usual training. But because I just had food poisoning a couple of days before, it was too hard
the entirety of
for
that
me.
sort of allostatic load, as it were.
Exactly, right? And this is what a lot of people don't understand. And what I see is the big problem that a lot of people, even medical doctors, are recommending universal protocols, right? That this is your longevity stack of like hormetic stressors, and everyone should do this exact thing every day. And it's insane. And it really speaks to poor comprehension of how hormesis works and how our physiology works.
Yeah, no, I couldn't agree more on this. I think it's definitely something we can come back to a bit later on. My apologies. I'm the king of tangents. I'm ADHD on top of everything else. But I'd like to maybe take a step back quickly, if that's okay, Alex, and then and talk more about how molecular hydrogen is working now. In our sort of initial discussion, I wanted to go down the sort of the mechanism of hydrogen ions and how they sort of drive the production of ATP through the electron transfer chain, all of that. And you thankfully put me on the right track and sort of sort of pointed the conversation more towards sort of the Semitic side of things, which is what we'll discuss now. But at sort of a molecular level, I mean, you've already sort of alluded to it with this discussion about hormesis. But how is molecular hydrogen fundamentally working to improve the function of the cell of the mitochondria and subsequently improve the health of the individual?
It's closest to hormesis, but it's not really hormesis because we haven't found the upper limit where it's harmful. It's sort of like an anticipatory stress, which our body expects to be a stress, but is so mild that it never seems to appear toxic. Now, we clearly evolved to anticipate this. Um, if you look at our last universal common ancestor, it actually fed on hydrogen as its fuel source, right? That spawned all life on the planet. Our mitochondria came from eukaryotes, which was sort of like a handshake deal between, a hydrogen producing and a hydrogen consuming, you know, organism, and went out to that carried on through us. Now, in living things, including humans, we all have bacteria that produces hydrogen gas, and much more relevant to human evolution. Um, we make our H2 endogenously by fermenting fiber. Now, if you look at the diet, our ancestral diets in our hunter-gatherer stages before the last 10,000 years of modern horticulture, we were consuming 100 to 150 grams of dietary fiber per day, right? Tremendous amounts. Today, the average person in the Western world gets 10 to 15 grams, but that includes like raw food vegans, right? Who are
Oh,
getting
wow.
like 60 to 80. The average person on like a standard American diet, eating like a fast food and takeout food diet, is getting 0 to 3 grams of fiber a day. So
I want to talk
bacteria,
about the carnivores.
yeah, yeah. So bacteria is like any other living thing, right? If you stop feeding it, it dies, right? And so we now know that even supplementing with fiber for a lot of these people, once you hit middle age, you've had a poor diet, you haven't eaten fiber your life, the hydrogen producing bacteria have died off, and what has taken over are methanogens, which are producing methane, right, instead, and actually consuming hydrogen. So you end up with this hydrogen deficiency. And hydrogen seems to be this ancient signal that we have. So yes, there's a very, very mild direct stress to the mitochondria that attenuates NFKB, so that's how it's regulating our inflammatory responses. It's activating the NRF2 pathway. That's how it's regulating the redox status, so the harmony between our endogenous antioxidants and our beneficial stressors, right, like nitric oxide and H2O2 and H2S and so forth. Um, so hydrogen is kind of this supervisor. It's a signal that comes, and the dials start getting turned. So hydrogen doesn't activate or inhibit anything universally. You look at all of these markers that we see in the literature, and there's examples of hydrogen, activating them or attenuating them, inhibiting them, right? Depending on the context, but always for a beneficial response. So, for instance, in the longevity space, a lot of people talk about autophagy. And you think that you always want to activate autophagy, which is simply not true. There's a lot of instances where you do not want autophagy activated. So, hydrogen, in many instances, activates autophagy, but in key instances in the research, it has completely inhibited autophagy, such as after drowning resuscitation, after heart failure, right? These are instances you don't want autophagy happening, and hydrogen's inhibited them. It's the same thing with oxidative stress and inflammation. Now, these are important parts of our physiological function. What's dangerous about them is when they're chronically dysregulated, either too much or too little. More often than not, it's too much, but there are plenty of instances where it's too little. So, for instance, a lot of antioxidants, like they don't work. The research has shown that high dose antioxidant therapy leads to higher all cause mortality, right?
Reductive
Higher,
stress.
yeah, reductive stress, exactly. So antioxidants can be good for some people some of the time, because if you're in chronic oxidative stress and you have some more antioxidants, it can bring you back down. But if you're just loading up the dose and taking more and more and more, and you're doing that every day, you reach a point where you go into reductive stress, which is just as harmful as oxidative stress. Um, Hydrogen actually is not doing this. It's regulating our endogenous productions. It's not working as a direct antioxidant. So there's some cool research in say, rats doing forced swim tests. And this is a model that we use to evaluate stress, exercise-induced stress. In the hydrogen plus forced swim test group, the rats actually see a higher spike in oxidative stress and inflammation. So their stress response gets potentiated, but then they rebound to homeostatic function faster. So it's as if they worked out harder and recovered quicker. So hydrogen is not blunting the hormetic stress response, the adaptive stress response of stressors like exercise. It's in fact potentiating them, but then protecting against dysregulation and bringing you back to harmony faster.
So all the gym bros can relax about them taking. It's not like taking a high dose vitamin C after your workout and then just
Yeah,
losing
it's not going
all
to
your
blunt your
gains.
hypertrophy
Yeah.
gains at all, right? It's
Okay.
actually going
Cool.
to potentiate them. So that's really interesting, and this is what we're seeing, and hydrogen is doing this for a lot of markers. I know in our talks you mentioned PGC1 alpha, right? And a lot of these markers that are linked to things like caloric restriction and fasting, hydrogen seems to mimic them. Sometimes, in the right context. Now, what I find very interesting, and I still don't have a full grasp on what this means from an evolutionary standpoint, but throughout our hunter-gatherer phase, our times of caloric restriction were typically the inability to hunt and secure meat and fat. So we would have relied on more plant-based food sources, which back then had far more fiber and were less calorically dense. So we would have been getting enough nutrients and enough fiber, but we wouldn't have been getting enough calories and enough protein, right? Going to this deep, like fasting like state, this caloric restriction that activates all these pathways. Well, interestingly, during these times of famine and fasting, their hydrogen endogenously would have been amplified, like our ancestors, because they would have been eating more and more plant-based foods full of more fiber. So they would have been getting these huge erratic spikes of hydrogen, which perhaps protected them in these times of famine. And perhaps this is a signal that we've brought with us to modern times.
So almost a protein sparing effect, you think?
Well, we do know there's one interesting study in Drosophila where they stop food source, on these fruit flies to see
Yeah.
how long they survive. And the group that's been supplemented with molecular hydrogen, they survive for substantially longer than,
Okay.
the fruit
The
flies that are
control.
the
Yeah.
control. Yeah. So there's some interesting factors there. Again, like not only is it activating these caloric restriction type pathways, but it's preventing death and harm from extended. So it's regulating our response to these physiological stressors.
Yeah. That's fascinating. Um, okay. Well, you've definitely answered all my questions there, and I'm glad to see that you sort of at least agree on the fact that, well, sorry, poor choice of words, that you like my idea that it's going to also support mitochondrial biogenesis by way of potentially upregulating PGC1 alpha, which for the audience is I think it's technically speaking, a transcription factor that then drives the production of more of these mitochondria within the body, which for most people, which is something I think a lot of people seem to forget about, is they don't realize that there is this high level of mitochondrial turnover that's constantly happening. And as you alluded to earlier, like everything else, mitochondria become damaged. And when you're in a highly inflamed state, you're going to not only lose the capacity of those mitochondria, but you're also going to lose mitochondria in tandem. I mean, I'm sure you're familiar with Dr. Robert Navio's work on the cell danger response. I'd be actually quite interested to see what he thinks. Are you familiar with the cell danger response?
No, not off the top of my head.
Okay, so Dr. Navio, it's more of a thing in the sort of the CFSME community. Obviously, people are struggling with your chronic fatigue syndromes, but Dr. Navio posits essentially that when the cell is stressed, the mitochondria particularly is going to go into what's called a cell danger response state. And it's going to which is going to inhibit the ability to utilize fatty acids to drive ATP production through oxidative phosphorylation, and that they're then going to sort of rely more on glycolysis. And in doing so, you're going to downregulate the metabolism of that cell to the extent that it actually is not able to, that you then start to lose the ability of that cell to effectively communicate not only with neighboring cells, but also just to produce ATP in the effective range. And you cycle through what is essentially cell danger, CDR1, 2, and 3. And individuals who are in this CDR state tend to sort of get stuck in CDR1 and 2, which are these states of cellular arrest. And I'm just sort of trying to plug it all together here, but I would be quite interested to see what molecular hydrogen would do with regards to his work. I'd be happy to send you over some information on his work afterwards.
Send it. I'll take a deeper look for sure.
Yeah, no, I think it's definitely one of the metabolic theories that explains a lot of cellular dysfunction, and not only chronic fatigue, but why people get stuck in a state of chronic inflammation and in a state of chronic hyper immune reactivity as well. Alex, I'd love to have a deeper dive into hydrogen and the gut. Now, I know you've talked about this previously, and maybe I'm butchering this, so please feel free to correct me if I'm wrong. But from what I understand, hydrogen is involved in the production of short-chain fatty acids. Is that correct?
So we don't know the exact mechanisms yet, but we have shown in research that it can increase certain short chain fatty acids like propionic acid, butyrate, acetate. There's been quite a number of studies showing improvements to the microbiome. We've again shown with the tablets that we can reduce calprotectin. So there is a lot of gut protective effects that are happening. We can activate hormones in the gut, like we've regulated ghrelin and GLP-1 in clinical trials and preclinical trials. So there's a lot of gut-based responses that are happening that mechanistically we do need to uncover more, but it could in part be due to this constant ebb and flow of gases that we have in our gut right now, and how modern lifestyle has dramatically shifted this dynamic away from what we evolved to expect. So by supplementing, with high dose hydrogen, especially for the gut water, because it's getting into your gut, this could be basically substituting for what we're lacking in our lifestyle.
Okay, and just on that train of thought, if you've got more of these short-chain fatty acids, one would assume that you're going to sort of develop more Akkermansia and other beneficial bacteria. They're not only going to increase.
And there is some research that hydrogen can increase Akkermansia too.
Okay. Directly.
Well, that supplementing with hydrogen water leads to higher levels of Akkermansia. Now, whether that's direct or not, we don't know. Most of the things hydrogen is indirect, because when it's tipping the scales on our system and it's dialing up, dialing down in all these various ways, there are countless downstream changes that occur, right? So with everything hydrogen, it seems to be largely systemic, at least to the tissues that are being properly saturated. So it's still unraveling the rat's nest of what's downstream of what in terms of hydrogen's action.
Yeah, and excuse me, and then just on the GLP-1 side of things, have you done any investigations or into research as your team into the metabolic effects of hydrogen, maybe say relative to something like a GLP-1 agonist? Is there any data out there to show that these compounds are effective at helping to regulate those satiety hormones?
So we have, I think it's now 7 clinical trials showing substantial improvements in body composition and metabolic health, including ones that are under peer review right now. We've regulated, like I mentioned, GLP-1. We returned the peaks and valleys to ghrelin, showing proper hunger responses. We've modulated the neurochemistry involved in satiety. We consistently show improvements in various metabolic markers as well, such as blood sugar, insulin, cholesterol, triglycerides, everything like that. Again, it's going to be a lot more subtle than throttling a GLP-1 agonist full time, but hydrogen isn't a sledgehammer, right? What it is it's a fine tool to recalibrate, and then over time your body slowly gets more and more efficient and does things more and more properly in how we evolve to behave. But it's not going to be shocking changes overnight. We're seeing the best metabolic effects after 3 months, 6 months. Like the longer you take hydrogen, the better the results are getting.
Yeah, no, I mean, that makes perfect sense, of course, because I think people take this sort of very reductionist view of appetite at the moment anyway, that it's just GLP-1. But when you're in an inflamed state, and as most people struggling with metabolic disease are, you're going to have high levels of inflammation. You're going to have low levels of dopamine. You're going to have dysregulated ghrelin, dysregulated leptin signaling, all of which are
Yeah.
going to feed into this cascade. It's not just about the GLP-1. And subsequently, if you can work to improve that environment to sort of remodel or regain that homeostasis, I would imagine with something like molecular hydrogen, I would assume that you are then rebalancing the entire satiety system within the body. And I suppose it's just taking a sort of a roots cause approach to it, opposed to, as you sort of mentioned, it's just throttling GLP-1 and hoping to God you don't end up with pancreatitis in 10 years' time.
Yeah, and that's the thing. Hydrogen is it's not acting like how we define a drug. It's not having a direct effect on a certain receptor, right, or enzyme in the body. Like hydrogen is playing this regulatory role, like a supervisor within our cell that's directing subtle changes, and then our body starts to correct its own path.
Yeah, definitely. What do you think about the idea of sort of running a GLP-1 alongside something like molecular hydrogen? I know it's a bit of a blunt, a sort of low-hanging question, and definitely something that you'd want to sort of just clip on a reel. But I think that's something that people would want to be interested in. Is that, just speaking from your own position, would that be something that you would sort of, well, not endorse, but at least hypothetically say is a good idea?
So actually, this gets into what I think is the future of the research, and we've now published a number, I think half a dozen of preclinical trials, and we have many more that are either under peer review, under manuscript prep, or in planning, where we're utilizing concurrent use of the hydrogen tablet delivering an approved pharmaceutical ingredient, right? An active pharmaceutical ingredient. What we're finding over and over again is that hydrogen is acting synergistically to potentiate the responses of these drugs while also mitigating the side effects, right? So it could lead to futures where a lot of these drugs, we can be delivering them in much smaller dosages, also reducing the side effects, getting better results, and improving people's health. Because there are many, many instances where we do need direct pharmaceutical intervention, for a lot of specific states. So actually there's certain, GLP-1 agonist molecules that are available in, say, powder form that we've identified on our short list to be doing research to look at the combination usage of them with the hydrogen tablet as a delivery method. And this is a future channel I am going into that we are actively going down. It is exploring the use of the hydrogen tablet as what's called a pharmaceutical excipient that enhances the
Bioavailability of the compound.
or reduces side effects, like basically a functional excipient. So I don't want to register hydrogen as a drug. I don't think it fits into the drug dynamic. I don't think it works as a standalone drug on any one disease, but basically getting it through the regulations like this, a whole wide array of pharmaceuticals could be added to the tablet delivery method, work complementary or synergistically, reduce side effects, and basically be great for everyone involved, from the pharmaceutical companies who are putting in less of their expensive ingredient to get the same effect and probably charging the same in the market, so making more profit in that sense. But for consumers, getting better health results with lower side effects, and better long-term improved health. So it's something I'm really excited about, and that's what we're going to be going down more the next few years, 5 years, 10 years.
I mean, that's incredible. I mean, I was aware of the fact you were compounding molecular hydrogen with various nutraceutical agents, things like PQQ, I think chromium as well. There are a few tablets on the market that you've got that include those specific molecules, but I didn't have any inclination or understanding that you're going down the pharmaceutical rabbit hole. So that's incredibly interesting, and yeah, no, I look forward to seeing the results of that. Unfortunately, I'm not a synthetic chemist, I'm a biochemist, so I can't offer you any insight there. But yeah, no, that sounds fascinating, something I'll definitely keep my finger on the pulse on. Now, Alex, I've heard you sort of talk about and discuss various other ways in which hydrogen can be introduced to the body. As speaking of other ideas you have, I suppose. Looking at it from a topical standpoint, I know it's inhaled. Do you think that there's a sort of a solid future there as well? I mean, I foresee molecular hydrogen being utilized from a topical standpoint to maybe deal with the autoimmune conditions like eczema and psoriasis, where there's a high inflammatory load just locally on the skin, and obviously I assume too, just speculating here, that there would be some sort of anti-aging effects from
Yeah,
sort of.
wrinkle reduction. There's actually research showing reduced wrinkles, with bathing in hydrogen water and elderly subjects. So I think the future, we're going to drink it, we're going to bathe in it, and we're going to inhale it. And when you look at all three of these routes of administration, they all have different pharmacokinetics. They saturate different tissues to different extents. So there is some crossover, but we're going to be able to identify better and better as time goes on. For this model, we want to say bathe and inhale or bathe and drink, and we're going to be able to develop better suggested protocols. Now, I do want to say again, with all hormetic agents, developing these standards in double-blind RCTs are important from a population standpoint, but every person is going to have different results, and you're going to want to adjust it based on your current state. But we will be able to identify at least that inhalation is better for this, drinking is better for that. For instance, what I'll say, like bathing, obviously it's getting to a higher concentration, far higher in your skin, in your muscle and connective tissues and such. Inhaling, it's obviously getting higher to your lungs. It's getting substantially higher to your muscles and skeletal tissue than drinking, but not bathing. It's getting higher to your brain than drinking, but drinking the water is also activating gut-derived hormones like ghrelin, which have an effect on the brain. So I think for brain issues, you want to inhale and drink. Drinking is obviously getting to your gut the best. It's interacting with the microbiome the best. It's getting to your liver at the highest concentration. So a lot of the metabolic outcomes of hydrogen are best through drinking high concentration water. But we're going to be finding out more and more as time goes on. And this is a real area of research focus to figure out which method at what dose is optimal for what condition. And, I've dove into the inhalation space where we're just gearing up to announce the soft launch of Inhale H2. That's a project that myself and Dr. Tyler LeBaron have worked on for 7 years. He's joined us as our chief scientific officer. So this is the first product he has ever endorsed because he's the co-inventor, and it is truly new and novel. We are the first inhalation device on the market that matches what can be done in the research. You can basically choose anywhere from 1% up to 4% with every decimal point in between of hydrogen and your time. But the key is it's a full rebreathing mask with the bladder. We've developed the system to mimic human breathing. So every breath you take is that controlled exact percentage of hydrogen. Whereas with these cannulas, you might breathe in a liter, 2 liters at once in a deep breath, but that's in 1 second. And now you didn't get 100% of that hydrogen in. That breath is maybe 0.1% or 1%, depending on the flow rate of H2, because these nasal cannulas are a constant flow rate and they're trickling in, and they're a fraction of what your actual resting rate of inhalation based on minute ventilation and tidal volume are. And most of the H2 is just
Circulating
wrapping
around
out
your
and coming
head.
straight out your
Yes.
mouth, right?
Yeah, it's a
So,
bit of a Hindenburg waiting to happen right there.
yeah, so we developed this machine to mimic human breathing and to work like they're not using any of these machines from China or Japan in the clinical trials. They're mixing gas tanks, and setting them to 60 or 100 liter a minute flow rates so that every breath you take is guaranteed to be that dose. We figured out how to do this with these one-way valves in this inflatable bladder, where even at a 12 liter a minute flow rate, you can guarantee that every breath you take is the exact percentage.
Yeah, I believe, and again, correct me if I'm wrong, but I think the issue with the Japanese units was that they just underdosed the amount of high. They got
The flow
around.
rate,
Yeah, they
yeah,
got
the flow
around.
rate is wrong.
Yeah, so you ended up underdosing it.
Yeah, so basically, we breathe at rest, like say sleeping, 6 to 8 liters a minute. As we're sitting talking at a computer like this, we might breathe 10 liters a minute, 12 liters a minute, even. Um, Most of these machines at the 4% gas are at a constant flow rate of 1 or 2 liters a minute. Now, at a constant flow rate, so it's just coming in at a constant rate, you'd actually need 60 to 100 liters a minute to make sure that every breath you're taking is at 4%. Um, so that's what we've resolved. All you can breathe is from the bag. Everything you get is from our reservoir, which is a bladder that fills up and then contracts. So you can open the door and see the bag filling up, contracting, with your breath, and you know that everything you're getting is just 4%.
That's incredible. What's the ETA on that project again? Do you?
So our betas got great feedback. We've made all the changes. We're actually just finalizing like more of like the processing details.
Okay.
Like of our, we're putting out a soft launch offer. So we have such overwhelming support. Between myself and Dr. LeBaron's connections, everyone wants this machine. The last thing we want to do is order like 30,000 of them
Yeah.
and find that there's a problem, like a small problem on
Yeah.
one that derails our launch. So we're doing a limited launch of a large but relatively small amount for relatively large but small amount compared to what the demand is, um, of some really trusted networks who know both Tyler and I well, and know that we're going to treat them right. Because again, even if everything's great on the machine, selling, ordering 30,000 machines, selling 10,000 machines a month or something, it's going to be difficult to scale up enough like service techs, like engineers
Yeah.
and customer service and everything to make sure everyone's getting the experience and the support that they deserve and that we want to give them. So that's why we're doing this kind of soft launch test order, to make sure that we have the infrastructure enough to scale up to make sure that everyone is getting a very high level experience.
Yeah. Well, I'll definitely start saving my pennies. Um, just quickly on that one again. So is this going to be sort of direct to consumer, or do you sort of foresee it being a sort of a clinical tool to begin with?
Yeah, so we have a lot of networks of spas and functional practitioners that want to be onboarding these. but there'll also be the direct consumer.
Okay. That's brilliant. Well, that gives me a bit of hope then. Alex, and I want to be aware of your time, of course, but I don't think we could have a conversation about molecular hydrogen without at least not quickly discussing hydrogen generators. Now, as I mentioned earlier, I've listened to a few podcasts you've done just in preparation for this one, and I know that it's just based on what you said in the past, that they do seem to sort of struggle. I know you've mentioned something called Henry's Law, and that there's an issue with gaskets there. And the fact that these units can't necessarily produce the amount of hydrogen that they do on day one, on maybe day 5 or day 10. Is this something that you envisage maybe solving yourself? Is this a problem that you would like to tackle, or is it sort of a bit outside your wheelhouse at this point?
So, funny enough, I have a patent on a bottle that uses the tablet to generate hydrogen that I developed years ago. And we knew all these problems were existed. And, we didn't use Chinese engineers. We used engineers, well, in Canada at the time. Ordered all the parts in, built them ourselves by hand with this engineering firm. We were getting like concentrated 13 parts per million in these prototypes we built, right? So stable, clear, you can drink. We thought there was going to be great applications for this. But even getting gaskets that were rated like 5 times higher than what like we needed, not a single one of the units lasted 10 uses before the gaskets were separating. But even if the gaskets get better, what we started noticing is the pressure, because we're getting to 130, 140 psi of pressure. It was starting to unscrew the bolts, right, from the force, right? So we were getting leaking from all sorts of angles. And I want to say that just think about this concept. This table that my computer is on, maybe it's rated for 200 pounds. And say I take a 40-pound weight and I drop it from a couple inches once, table's fine. But you just keep picking that up and doing it 5 times a day, every day, there reaches a point in not too long where the table breaks,
You sort of hit
right?
that point, limit of material fatigue, yeah.
Yeah, exactly. So this is how these pressurized bottles work. Is yes, no matter how high up you go in the rating, it's that repeated below pressure which eventually breaks them. And just think about how a drop of water can carve through a mountain, right? Just a constant drop over and over. In time, it will break. So the question isn't if these machines can ever not break. They will always break, right? It's just how much does it cost to make sure that they last 6 months instead of 6 days to like a couple weeks, or and how much does that cost to do, right? So none of these manufacturers seem to be improving on this, which tells me that to make improvements is going to drive up the cost so much for not a good return on longevity. And like I said, we were rated, I can't remember, but our gaskets were rated to something like 750 psi or something like that, and still they all broke in under 10 uses.
So it's let me get this right. So it's a bad solution relative to, say, the tablets, which have a low barrier to entry in terms of cost, have a high yield in terms of the amount of hydrogen that they
Well, yeah, and that
output.
they're
Yeah.
consistent every time. So even at their best, these bottles that are getting up to 5 parts per million, well, that's 5 parts per million in typically 250 milliliters, right? So that's 1.25 milligrams of H2. We're getting 12 parts per million in 500 milliliters if you prepare and drink it as we suggest, which is 6 milligrams of H2. So we're getting close to like 5 times as much hydrogen when these bottles are new. And then all of a sudden, a month later, now we're getting 30, 40 times more hydrogen. So even when they're brand new, they are not getting close to the dosage that we're getting. And they break pretty fast. And not just, even if they solve the gasket issue, there's a secondary issue of the membranes slowly start breaking down, right? And as they break down, maybe they're releasing heavy metals. We don't have the data on that yet. They're a consumer device, so they're not legally mandated to post long-term safety kind of info like that. We know that DuPont, has put cease and desist to all the Chinese manufacturers that they're not allowed to use their membrane because their membranes aren't rated for contact with something that's for human consumption. So if DuPont is stopping their sales, saying that this isn't intended for human consumption, that tells us DuPont knows something, or at least to me, it suggests DuPont might know something that the Chinese manufacturers don't yet. So they've almost all switched to their own membranes now because DuPont has removed the ability to use theirs from so many of these manufacturers.
And
But
those, I assume, are questionable as well.
it's I'd just like to see the data. I don't want to say definitely this is going to deliver this or be harmful. It's just too many questions that I wouldn't personally use it, until those are answered. But then the final kicker is to make these machines. One, you don't want glass because that becomes a bomb with shrapnel.
Yes.
So you have to use plastic. And then with this repeated pressurization over and over again, how many microplastics and PFASs are you getting into the water? So that's another question.
Yeah, no, definitely. Like I said earlier, I think it's just finding a complex solution to a problem that already has a simple answer, in this case, tablets. Um, Alex, you've been amazing, truly, and maybe it's just me, but I get way more starstruck talking to someone like you than I ever would a Tom Cruise type. Um, Before I let you go, though, and I do need to let you go, I'm aware of that. Would it be okay if we just ran through a few rapidish fire questions quickly?
Yeah.
Okay, brilliant. Thank you. All right. So just off the bat, you mentioned this a second ago, but what's the best way to use molecular hydrogen tabs?
I think that the best way is one, room temperature water,
Hmm.
right? I designed it for room temperature water. Now, the reason for that is we can't really guzzle or chug cold water or hot water. So we designed it to react ideally in room temperature water. You don't want it to be highly alkaline and not distilled either. So you want a little bit of electrolytes like TDS in the water, but really anywhere from 3 parts per million to 200 parts per million. So basically every bottled water on the market and every remineralizing RO system and every tap water source, other than if you're in like a well, super hard water is going to
Yeah.
work fine. Just don't use like alkaline ionized water or like highly alkaline mineral water. Don't use carbonated water, which I know is a lot more popular in the UK and Europe than here, because then the hydrogen is competing with the CO2 for partial pressure, and the CO2 wins and it sparges out the H2.
That was screw with the zeta potential. Is that right?
Yeah, so I mean,
Okay.
one, it's going to disrupt H2. Only so much can stay in. It's going to force out the. It's not going to allow saturated H2. There's going to be more collisions, which increases the bubble size of the quasi-dissolved H2. So it's just going to lead to a bad result. I'd say 500 milliliters is what we designed this for, but the best volume of water is what you can guzzle rapidly. So, for instance, in the elderly trials, we use 250 milliliters. In most of the middle-aged like metabolic trials, we use 330 milliliters. Right. So I guzzle a liter first thing in the morning, but I'm a big guy and still exercise a lot, and I can chug a liter first thing in the morning with a lot of my supplements. Most people can't. Uh, so I put a few tablets in a liter and chug it down. But again, most people can't do that. I will say you want to take it on an empty stomach, right? I do have IP demonstrating that hydrogen in an aqueous solution that has dissolved polysaccharides retains the H2 nanobubbles and creates gels and foams, right? So that's going to happen in your stomach. And actually, that there is data, like someone unaware of my pending IP at the time about this made these hydrogen-rich like Jello. Right, it was a physicist in Vegas that I ended up talking to a bunch, and he dropped the project because he found out about my IP. But they were measuring the hydrogen leaving in the urine after. I'm like, well, if it's all leaving in the urine, then it's not circulating in your body. So hydrogen works by like other hormetic stressors. You want this spike and then this return to baseline. So you want a peak and a valley. So you don't want to eat it with a meal heavy in like carbohydrates or fiber because they're going to retain the H2 and it's not going to hit that rapid spike into your cells.
Yeah, definitely. Next one. Have you ever thrown down a tablet down the hatch and then chased it down with a little water? Have you sort of ever done that?
So I don't recommend it because I have when I'm in a rush. I know Dr. LeBaron talks about it. He does it when he's in an absolute rush and doesn't, like, he's late walking out the door. I'm late walking out the door and I don't have like a minute to spare. Why you wouldn't want to do that is if you don't drink enough water, right? And then you might get some unpleasantness in your gut. So we can't recommend that. People are really, really bad at judging what enough water is. I see, even when I see people like, even people I'm friends with or family members, and I'll see them drop like a tablet in like 50 milliliters of water. And I'm like, what do you think's going on there? Like, stop doing that, right? So I see that and know that if I tell people, yeah, you can swallow it and chase it with water, they're going to swallow the tablet and take a sip, right? And now that's not nearly enough water. So you're not going to get the same therapeutic effect, but moreover, you're going to potentially make your stomach upset, right? And long-term use of that, maybe you're going to develop an ulcer or something. So don't do that. I mean, there is a way to do it safely, but there's not a way to advise it to people who are going to listen and do it safely, if that makes sense.
Yeah. Is there any, quick tangent on that one. Is there any exothermic reaction or heat developed that
Yes.
could be,
Yes.
okay,
Yeah.
that would also
Yeah.
be an issue, I'd imagine.
Yeah.
Okay, moving on quickly then. Besides molecular hydrogen, what single molecule excites you the most when it comes to supporting health, supporting, yeah, human longevity? That's in the pipeline perhaps, or something that may already exist.
Yeah, I mean, I know we've talked about tesofensine. I really like that molecule. I'm getting it off the black market. I've basically quit drinking and have no desire to drink alcohol since I started tesofensine. I have much less cravings for food. Um, Other than that, it's hard to pinpoint um, a single molecule. Like, I probably take 100 pills a day, and then like liters of supplemental liquids and stuff. So it's really, really difficult to pinpoint one thing. And especially with everything, um, it depends on the context. Like, for instance, something like methylfolate, right? When I was getting off um, testosterone replacement and trying to regain my fertility, high dose methylfolate, like 5 milligrams a day, has been linked to improving male fertility. But you only want to do that for like a month or two, because if you're doing that long term, and you're not countering it with
TMG
other
or
B
something.
vitamins, you like, yeah, I mean, because absolutely, like with something like TMG, um,
Just too many methyl
you're,
donors.
yeah, right, and it's going to lead to some problems.
Definitely. I mean, the moment you start playing around with the methylfolate cycle, it's the folate cycle. You've got to be careful, and you've got to have an understanding of your genetics as well. Um, okay, so I'll skip one, and the final question is, what's next for you on the health front? Obviously, you've been through this journey, and uh, I know there's still a long way to go. I know, I think you said you're a candidate for a few different operations. And what is what is next to you in terms of you trying to sort of optimize your health, if you don't mind me asking?
So with me, it's always just trying to improve, and I've been getting rounds of stem cells. They've helped a little bit. I need to keep doing that. I'm really actually excited about some other protocols that we're seeing in rodents but haven't jumped to humans yet. There's protocols where they're doing micro drilling into joints, even if there's just very small pieces of it, and injecting them not just with stem cells but various peptides, and block building, molecules. They're able to like completely regrow joints, in rodents now. But there isn't even the highest end clinic in the world that's trying these protocols in humans. So I'd say that is something I am desperately looking forward to try and actually regrow the joints that I've lost.
Yeah, no, I can only imagine. Alex, you've been a star. Truly, I appreciate this conversation more than you know. Where can people find you if they do want to learn more about you, if they do not want to learn more about hydrogen tablets? I assume you would point them to HRW, and then I know we mentioned it earlier, but just to plug your book that's coming out shortly.
Yeah. So alextarnava.com is my website. My Instagram is the same at Alex Tarnava. I have a ResearchGate account that you can read some of the papers that I've published or co-authored on. Again, it's Alex Tarnava, my ResearchGate. For the tablets, I mean, I supply to like 100 brands. With the Drink HRW, I've written a lot of blog content for them. There's a lot of good content I wrote. Some of it is pretty dated. I would have written it 4 or 5, 6, 7 years ago. But even the dated stuff is still mostly accurate. There's just new
Yeah,
information that could be rewritten, but that's really on them to update it. I can't
yeah,
be rewriting stuff for them
of
forever.
course.
But yeah, those would be the best spots. If you're on my social media or on my website, you'll see the new podcast editions that go live. You'll get announcements for my books as they're coming. So I actually released one book, but then I read it after it had gone through the editing process, and I learned a lot because I had approved every paragraph that was being edited, but just looking at the paragraph through kind of like a keyhole, and I didn't think to read it chronologically. And then it came out, and then I pulled it because I started reading it chronologically. I'm like, oh man, this has lost nuance. It's changed my voice. It's, a
You
little
just weren't happy with
repetitive.
it.
And
Yeah.
like, so I pulled it. That's being rewritten. But actually, I think it's more fitting because the book that I wanted to release first, Stress Hacked, I was going to release second because the Final Thought War was complete and Stress Act was only about 90% complete when I made this decision. But now Stress Act is complete going through editing. So now I'm having to redo the editing of the Final Thought War. So they're going to get reversed, which I originally wanted it that way anyways. But I've written to various levels of finished 7 books right now. So they'll be slowly released over the next few years.
That's impressive. I'll definitely be getting every single one of them. And as I mentioned during our sort of initial correspondence, that's impressive because I'm still trying to come up with the concept for one. Um, Alex, again, thank you so much for your time. This was, again, at the risk of being verbose, truly a pleasure, and I'm just grateful for the opportunity to talk to you this morning.
Awesome. Yeah. Thank you very much for having me.